a short introduction to what the SixNet project is and what we've been doing over the past year, and then give some pointers as to what we'll be doing over the next year. I mean, much of what I'll be discussing will be covered in more technical detail later in the workshop. So really this is just to give you a sort of high-level view of really what the project is doing and what type of work we're undertaking, what type of activities we're doing. So just a quick high-level view. SixNet is a 3-year project to, well, the idea is to prepare the next generation of the internet. IPv6 is one of the technologies that we believe that will be important in the coming years. And this project started in January 2002. It's actually one of the largest IST projects, one of the largest projects in the European Commission's IST program, representing a total investment of around 18 million euros. So as I've already mentioned, it's a major international native IPv6 testbed. And although we're very wary of making claims that you can't substantiate, we think that it's probably the largest in the world at the moment. So the main objectives are to, of course, firstly to install and operate a pilot IPv6 network. And this will be mostly operated with, or is mostly operated with native links, native connections. And what we're doing with this is to test the migration strategies for integrating the IPv6 networks with the existing IPv4 infrastructure. And then to introduce and test the new IPv6 services and applications, and also see how well the existing legacy services and applications will run over this. We're also looking at address allocation, routing and DNS operation, which works slightly differently from the conventional IPv4. And then we're also have a role to promote the IPv6 technology and to work with other projects such as Euro 6 and maybe identify areas where standardization could be improved. So we have 35 partners within the project, and this is quite an interesting consortium that we have a number of industrial partners, a number of national research networks, and also a number of universities. So we have the 6 partners, commercial partners, including Cisco, IBM, Sony, and then we have NTT Communications in Japan, and ETRI, which is a research institute in, well, semi-commercial research institute in South Korea. These are the NREN partners. I mean, I think probably many of you will be familiar with most of the names there, the usual suspects, I suspect. And then a number of academic partners. Just to mention that there were 4 new partners joined in September 2003. It was Chestnut, HungerNet, PSNC, which is the Polish supercomputing centre, and ETRI, which is the South Korean organisation. And they were brought in to extend the geographical coverage of the project. And also they brought in a number of, they brought in some expertise to develop a number of open source solutions. We're also looking at them to create and support a public repository of IPv6 software, which again, some of this will be mentioned later in the workshop. And then really, perhaps a bigger objective is really to spread the word of IPv6 further into the newly associated states. So, at the moment we're operating a largely native IPv6 backbone, which is currently running at 155 megabits per second. And there are several interconnections, firstly with the national IPv6 testbeds, with the Euro 6 project, which is another large IST project. At the moment that's interconnected via the UK 6X. We have a connection to Abilene in Internet 2, which is via SurfNet. There's a connection to NTT Japan, also via the UK 6X. And then we have a connection, ongoing connection to ETRI via Renater. Of course, we have tunneled connections to the 6-bone, but we're actually probably looking to deprecate those. I mean, the 6-bone itself is being deprecated in the near future, so these will disappear in due course. A 6-net NOC has been established to handle the monitoring and maintenance and fault reporting facilities, and that's running fairly smoothly. And we've also drawn up an acceptable use policy and routing plans.
Where's your NOC?
Marianne, it's Dante. It's actually in Cambridge, or is it in?
The 6-net NOC is in Paris.
In Paris. So we have this is the latest core topology. As you'll see, if I can find the pointer. I think it's that one. Where's the pointer? Oh, okay, well, it doesn't seem to be working. But okay, so you'll see. Right, there we go. Thanks. So we have this core here, which is running at 155, and this is running natively. We have a number of tunneled connections here to Poland and down to Greece. This is largely for cost reasons. That's just simply the cost is prohibitive at the moment to develop or to install native connections, dedicated native connections. The link to Hungary, that's actually incorrect. This is actually a native IPv6 connection. And then we also have one to the Czech Republic. Here, these are the ongoing connections out to Internet 2, to ETRI, and to Japan. The interconnection with 6net is here. There are two other interconnections planned. The one in Italy is still under consideration. One of the problems is that the Euro 6 point of presence is in a different location to the 6net point of presence. So there's obviously some issues there, and the same actually is the case in Germany. But we're currently looking at how to solve that problem. Okay. This gives you perhaps a better idea of the topology, exact topology. We have here the connections to the Nordic countries are provided by Nordinet, and I believe they're currently procuring their own IPv6 testbed. Okay, so we have the other activity. Yeah, it's not working. Okay, so we have several other associated activities. We're not just running a network. Obviously, we're looking at the, examples of how to operate IPv4 and IPv6 in a dual stack configuration. I mean, obviously, we can't expect networks to change to IPv6 overnight, so we'll need to run a dual stack IPv6 and IPv4 together for some time. We're also looking at running IPv6 over MPLS and ATM. Of course, tunneling IPv6 over IPv4. And then considering how we can implement the common services that you need to run the internet, such as a DNS, looking at transferring news and NTP. When we're looking at the tools you can use to transition the various networks, and then looking at how the issues for deploying native IP over fixed and wireless networks, such as WaveLAN or GPRS. So the aim of all of this is to identify the pieces that are missing, looking at all the different components that you need to put together to run IPv6, and then seeing if we can identify what areas that need to be worked on and what areas where there's this lack of software or lack of standards or so So we've actually produced what we call cookbooks. We've produced 2 cookbooks which give an outline of some of the issues that you need to consider when you're moving your networks from IPv4 to IPv6. And they're all available on the 6net website, of which I'll give you the URL later. Okay. So as I mentioned already, we've devised the routing plan and implemented the routing plan. This seems to largely work without too many problems, although obviously we're always refining that. The DNS support for IPv6 has been set up, and we've established a multicast overlay, which we call the M6 bone. And we've also established this multicast beacon, which again I think Stig will mention later in his presentation. The routing we're running is internally is IS-IS and externally is BGP+. I think that there's plans to look at other protocols later on, but we're at the moment keeping it simple, just getting it up and running, getting it to work. There's been some trials of DHCP version 6, not without problems. And then we're also looking at things like auto-configuration, service discovery, site local addressing, firewalls and security, which are all sort of features which IPv6 adds to IPv4, which is you don't have in the older protocol. Okay. We have a work package looking at evaluating mobile IPv6 implementations. I mean, this is perhaps one of the most interesting aspects of IPv6. Also one of the worst defined or least well defined. And really at the moment this is more of an investigation stage, not so much, hasn't been so much practical work done. But IPv6 has been tested over WaveLAN and cellular networks already. Looking at access control mechanisms and tentatively looking at IPv6 support for QoS. I mean, that's something that we haven't really done too much practical work on at the moment, but that will be coming in the coming months. We're also looking at VPNs and then multi-homing and renumbering solutions. Of course, as I'm sure many of you are aware, the multi-homing issue is still far from resolved even within the ITF, so this is a difficult problem. So that's the actual base network, and of course we should run some applications over this. So we also have a work package that will, which is considering the type of applications we can run and what applications you can run. So we divided this into 4 categories. The first being video conferencing and streaming. So looking at a number of applications there that we can either develop or we can port to IPv6. I think GNOME Meeting is an example of an application that is being ported from IPv4 to IPv6. Isabel has already been ported. That's actually not been done by 6net. That's been done within the context of the Euro 6 project, which Geordie may mention later, and several others. We're also looking at online gaming, and we've had Quake running over the 6net network. I think we even did that at the 6net review. And then looking at perhaps more business-oriented solutions, such as the production of the Globus toolkit and looking at IPv6-enabled directory services. And then finally, what we would call edge services. So an example would be proxy caching. So we're also looking at what are the requirements of user communities and why they might want to use IPv6, and then trying to target the applications that should be ported or developed first. And the intention is to demonstrate some of these there's an IPv6 showcase that is currently in the planning stage, but that will probably be held maybe probably be held around November 2003. And the plan is to demonstrate some of these applications. There is a mailing list available for an open mailing list where we're discussing some of these issues for porting applications, and everybody is welcome to subscribe to that. Okay, so then we looking at how we can manage all of this, and one of the problems with IPv6 is there's not so many many of the common network management packages are simply just not available for IP version 6. And then there's also no support for a lot of the new features of IP version 6, such as auto-configuration or mobility. So we need to do some work on that. We've also established the 6NCC, which is for maintenance planning and fault reporting, and failure notification, the type of things that you get in a normal production network. But we're looking at this and looking at the issues involved and what you might need to do, what you might need to do differently if you're using IPv6. And we're also developing a number of traffic measurement and visualization tools. Again, I think some of these will be mentioned in more detail later. A hot issue, of course, is denial of service detection. So with some work being conducted on that. And then, of course, with respect to SNMP, this is a very commonly used within the IPv4 world, so it's natural that we should do something with IPv6. And then we've also produced a network management cookbook, which summarizes many of these issues, which is also quite an interesting summary of some of this work. So as already mentioned, all of these cookbooks and a lot of the other results and other work is available on the 6net website. The URL is here. So there's newsletters, the cookbooks, there's some topology diagrams. We also have we try to maintain a calendar of IPv6 events around the world. So if you're interested in a particular aspect of IPv6, you might find something to suit you. We've had a number of training events in the past year to preach the word of IPv6. And then we've been also working in conjunction with Euro 6 to set up some interconnectivity. We're also looking at extending the multicast overlay. And then we've also been doing some other work on VPNs. I mean, there's several other activities that we're working on or we'd like to work on, but these are perhaps the most ones where we actually have some results at the moment. And then finally, the plans for the coming year. Well, within the first goal is to actually expand the backbone and to expand the number of tests that we're doing. Work Package 2 will continue to evaluate the tools that you need to transition from IPv4 to IPv6. In Work Package 3, they'll be looking at a number of looking at different routing protocols, things like access control lists, continuing to do tests on multicasting, looking at other issues such as security, general network operational activities. The work on mobility and wireless, VPNs, multi-homing, that will continue. We'll probably see quite a lot more activity within QoS. Then Work Package 5 will continue to work on porting many of these applications. I mean, I think there's a list of 40 applications to port, and that will all be forthcoming. And then within the network management work package, we'll be looking at things like NetFlow and other tools. And finally, there'll be 2 more workshops are planned, some more training courses planned and then there'll be more publicity events, and we'll also be collaborating with some of the other projects to publicise a lot of this work. But anyway, that will be, most of this will be explained in more detail later in the workshop. Okay, that's it. Video, yes. We have a short video to show which the project has produced, which just gives some we put this together during our recent consortium meeting, and this gives some ideas about what people feel about 6net and what people feel about IPv6, and it's quite an interesting review. So, the video. Yeah. Okay.
Sound comes out of a PC, you have to put a micro.
Yeah. Okay.
Sound?
Yes, yeah. Okay. Nearly forgot about the video.
It's only the very, very beginning of something very, very large.
The IPv4 address space is running out. Now, many people say, well, it actually isn't running out. There are plenty of IPv4 addresses left. Well, that's certainly true, but it's how they're allocated, and it's also where they're allocated.
If we don't do it, we're in very grave danger of being left behind.
There are some discussions about whether we need it right now or in 5 years or 10 years, but we definitely need it.
I mean, the protocol by itself is not that revolutionary. IPv6 should be pushed, say, politically.
Well, IPv6 technology is something which will have to come anyway, one day or another.
Tem movimentos de gota na canastra, a caravela, no coração a fragata, na canastra, a caravela, no coração a fragata.
It's difficult at one point in time to say who is the leader really, but it's important to be in the back of the first ones.
Well, it looks like Japan is leading it, but I think Europe is picking up speed, and we are definitely in front of the US, for instance.
Europe is leading the IPv6 projects in the world.
And European people
are more strongly involved in the IPv6 for research projects and even standardization process than they were for the IPv4.
I would say that Europe and Asia first, and then maybe America then, but we are in good position.
I would say Europe is probably in the middle if we compare with America and Japan.
We are ahead, I would say, compared to the United States and Northern America, but we are falling back a bit if we compare ourselves to, say, Japan.
I guess then Europe is just very closely behind.
I think we're pretty much leading now. I think we started off slowly, but I think we've seen the lights.
I think it's a very valuable project. Many of us have been playing around with IPv6 for quite a few years, but this is the first time one's trying to do it rather seriously in an organized way and with the right sort of equipment, the right sort of networks, the right sort of applications, and it's been properly organized.
It's something that hasn't been tried before. It's the largest IPv6 project of its type in the world.
Maybe the most important project we had in Europe for years, because we have 35 partners.
About 35 companies. And I'm not aware of any other project bringing together so many skills.
Last month we held a workshop where we disseminated some information about 6net, and again everybody's quite pleased about this project because there is a lot of information that's being shared and we're learning. It's a really good project.
There is a very interesting consortium consisting of NRENs, the Research and Education Networking Organizations, research sites, first of all universities, and also companies, vendors, equipment vendors and telcos. This combination is a guarantee of achieving really useful and realistic results. About half a year there is a consortium meeting, and after each such 6 months there are a lot of new results to be discussed, a lot of open questions which are just arising during the activities. So I think such consortium meetings are very important milestones in the 6net project. It would be better to have such meetings much more frequently.
Okay, well, hopefully that's given us some food for thought over the coming day, and we'll continue on to hear from what other people, how other people see IPv6 and where it fits in the future. Okay.
Thank you. We follow on with Euro 6AX update from Jordi Martinez. So Jordi, please. Yeah.
Hello. Is everything working?
Yes, we see you, Jordi.
Okay, perfect. So thank you everybody for giving me this opportunity. I'm really sorry not being able to be there in person. I hope you have a very successful meeting in general. I'm going to try to keep you updated about the last progress that we are doing in Euro 6. I will not go in deep to all the details of everything because, well, most of the people that is following all these projects already have heard a lot of times about Euro 6 and so on, I guess. So in any case, if there is any question, I will be happy to answer it. Well, just to remind, the goal of Euro 6 is to support the fast introduction of IPv6 in Europe, mainly talking about introduction in commercial networks, ISPs, telcos, and this is done mainly through the network design and deployment, researching on advanced network services, and developing and porting applications that must be validated by users, not just by the project participants, but also by external users. And of course, the dissemination and collaboration activities, some of these activities include the collaboration with 6net indeed. Just to remind about the consortium, we are 17 partners, 7 ISPs, the bigger ISPs in Europe, including Telecom Italia, Telefonica, Airtel Vodafone, BT, T-Nova, that is the research arm from Dutch Telecom, France Telecom, and Portugal Telecom. Well, in fact, most of the people that is involved in the project is not really the telco itself, but the research arm of each of the telcos that I just mentioned. We have also 2 industrial partners. One is 6WIN. 6WIN is a spin-off of Thales, Thomson actually. 6WIN was one of the first manufacturers of routers with complete support of IPv6, and the same with Ericsson Telebit. Telebit was, in fact, I think the first one in the world manufacturing commercial IPv6 routers, and was acquired later by Ericsson. We have also 3 universities, 2 of them in Spain. One is University Polytechnical of Madrid, the other one is University of Murcia. These 2 universities have been the first that started working with IPv6 in Spain. And then we have Southampton University from United Kingdom, that indeed it's the common partner between 6net and Euro 6. Also we have 3 companies that are dedicated to consultancy, system integration, network, and research activities. One is my own company, Consulintel, the other one is Telscom, and the last one is Novaginet, that is mainly dedicated to web portals and applications, and they are doing a lot of things regarding IPv6 and mobility, for example, apply it to webs. And finally, we have 2 companies that are in some way special, considering a research project. One is Eurocontrol, is the air traffic control authority and research arm in Europe, and the other one is a lawyer's firm. That's really very strange, because what a lawyer's firm make in a research technological research project. And the reason this firm ECIJA is in the project is because we believe there are a lot of questions or concerns regarding privacy, for example, with IPv6, that need to be well understood and properly applied, if necessary, in the legal scope of Europe. In fact, we have got already some good responses, because there are several groups at the European Commission level working in privacy aspects, and we are cooperating with them in this field. Regarding the network, it's mainly 34 megabit native links. These links connect the different internet exchanges. We have 1 in each country, so we cover Portugal, Spain, Switzerland, Italy, France, United Kingdom, and Germany. And in addition, the project partners are connected to the internet exchanges with 8 megabit links, usually also native IPv6 links. In some cases, there are a couple of cases where they use tunnels. I think, in fact, actually it's only one case in Denmark. And also we have a kind of tunnel in our own network and a backup through regular internet, just to close the ring of the network. So this is connecting Madrid and Torino. It's important also to mention that in London there is already connectivity with 6net, and we are working to get connectivity with 6net probably in Paris and maybe also in Torino. So this is again one very important cooperation point between both projects. Another important thing to mention is we saved a lot of resources, a lot of money from the connectivity point of view, because most of the links have been sponsored by the telcos participating in the project. So this is, I really think, very, very significant, because it means there is a real commitment from the European big telcos to move to IPv6 as soon as possible, and this is really a first step on this direction. Regarding the main research aspect of the project, this is the new Internet Exchanges models. So we have investigated actually 3 models. I am going to introduce only Model C because it's the one more innovative in the scope of the project. The others are models of Internet Exchangers that are already available today in IPv4 Internet. So in this Model C, what we have is a layer 2 infrastructure that is fully redundant, where all the Internet Exchanger services are placed. We have also routers that provide access to long-haul providers and customers, and we have a layer 3 mediation function that is the real innovative element on this kind of Internet Exchanger. So the idea is a mix layer 2 and layer 3 Internet Exchanger, when today Internet before offers mainly layer 2 pure Internet Exchangers. That's the big difference. So this way we can have what we call traditional customers, traditional layer 2 customers, and also next generation customers that connect directly into the layer 3 infrastructure. Regarding this model and the benefits, well, this is based in RFC 2374, and the idea is to verify that a customer can, for example, change from a service provider if the service provider is connected to the same Internet Exchanger, and don't need to change his addressing space, not need to renumber his network. So never mind IPv6 support in theory renumbering, but this is still not, let's say, well tried, and well, if it's something that we can avoid, we believe that it will be much easier for a customer to get into competition with new ISPs and provide and get better service and better pricing. Another important thing is we believe that Internet Exchangers could facilitate one of the possible solutions for multi-homing problems, and this is something that we still have not started. At the moment, the project has been working mainly in setting up a very, very stable network, and now we are moving to all these new functionalities. As I already introduced, the Internet Exchangers will play a very important role in the intermediation function between ISPs and the customers. And this is the reason why we have this layer 3 mediation function router. Regarding the routing in the Internet Exchanger, well, we are using IGBP and IGP inside the long-haul provider, and then Euro 6, it's a collection of different routers inside the Internet Exchange emulating with a single AS long-haul provider. So we consider our own network one of the, let's say, examples of the long-haul provider. 6net could, for example, be considered another example of long-haul provider, and 6BON either could be another one. We use also between the customers and the Internet Exchangers eBGP 4+, and also between the Internet Exchangers and the long-haul providers. Regarding the Internet Exchanger-based services, well, we really believe that being a concentration point or aggregation point, the Internet Exchanger can have a very, very important key paper and aggregate, for example, multicast traffic. But in addition, we believe that other services like AIA or quality of service or DNS and DNSSEC functionalities, transition mechanism, route servers. All these can be on the network layer, let's say, very, very important places where the internet internet exchanger could make a perfect match. And also regarding applications, well, it's a good place to set up web server farms, for example, or SMTP or FTP servers. Of course, services like or applications like video conferencing, e-learning, peer-to-peer applications, and finally monitoring services for the network itself. So any kind of tool to manage the network could be perfectly deployed on the internet exchanger, and from this point control not just the core network but also the access networks. Oops. One of the examples of internet exchanger that is already working and fully functional in the Euro 6 network is the London internet exchanger that belongs to BT. So this is actually already a layer 2 and layer 3 IPv6 internet exchanger. It's the first in the United Kingdom. It's already using commercial IPv6 addressing space. It's open, so it's not just a BT premises. It's open to any customer that want to connect, and Google selected some customers already working with this internet exchanger. And the main goal of this facility is to stimulate the IPv6 environment in UK and Europe and the rest of the world, and also to further help in understanding the IPv6 functionalities and performances that we can offer. Regarding the architecture, it's Ethernet switch for the layer 2. There is an ATM switch for several customers that have different access mechanisms. There is a router for the layer 3 functionality. You have here in the slide the address space that is used for the address allocation to the customers. This is something that I forget to mention. One of the things that the internet exchanger can offer in IPv6 as part of the layer 3 functionalities is getting the address space from the internet exchanger instead of getting it from ISPs. There is also a /48 for the infrastructure on the internet exchanger, and the maintenance is done with tools very well known like Looking Glass, ISPAT3 and so on. This is the graphic of the basic structure. So you see the router, the ATM switch, the Ethernet switch, the customers connected, the different services that are available right now, and also DNS, email server, web server, and so on. So you see the customers connected either through the Ethernet switch or to the ATM switch. Regarding the connectivity, there is, for example, another internet exchanger already connected to UK6. So this is Exchange Point Europe. There is a transition mechanism that is Ultima that was developed by BT Exact. It's an ATPT, and well, in fact, a little bit more sophisticated than just an ATPT box. It offers connectivity, of course, to 6BON, to Euro 6, obviously, to 6NET, GPRS V6 access, and there are actually several different trials ongoing on these internet exchangers. Another important aspect where Eurosys has done a lot of progress is DNSSEC services. University Polytechnical of Madrid is completing a DNS emulation environment. So we are developing a complex set of configurations and examples with DNSSEC through this emulation environment. There is a pilot where already University of Murcia, Consul-Intel and UPM are working, and we are publishing certificates using DNSSEC. So we are analyzing different models, like for example TSIG and SIG for symmetric and asymmetric keys, and we support the PKI V6 that was developed also in the scope of Eurosig by University of Murcia. and we are actually supporting with TSIG bind 9.2.0 and with SIG bind 9.3.0. There are actually two scenarios for these internet services, internet exchange services, which PKI V6 to publish the certificates using DNSSEC. The first scenario is the one where the root certification authority and the name server are together in the same internet exchanger. So that's quite easy to understand with the graphic. And the second scenario is the one where the root certification authority is outside the internet exchanger and could be located, for example, in another internet exchanger. Regarding security, this is another big area where Euro 6 is working. We have already a general definition of VPN's policy, and we have already tested this as one of the collaborations with 6net, with University College of London. There is already a very good knowledge about how we can enforce VPNs in 6WIN routers, and had been very well tested in several internal trials and public demonstrations. In fact, last week also in the Madrid summit. And with Cisco, we are right now waiting for the Cisco iOS version that could be accessible with support for IPsec for IPv6. And this is actually working with Cisco, but with IPv4 only. Another important activity regarding applications that Euro 6 is working on is instant messaging. We have already finished the version 1. This is instant messaging being developed by Southampton University in collaboration also with NGN. And there is this version 1 is Java based. It's developed using Java. We have already deployed and debugged the Java IM server. There is a GUI-based instant messaging client also. There is a very well debugged interaction between the client and the server, and we have migrated this to IPv6 already. So the services that this instant messaging version 1 supports is the user management, the roster management, the messaging application itself, the presence management, the group management, and the group chat. The next step in version 2 consists mainly in getting the client-related multicast messaging. It's based also in Java address scheme. Some clients could be configured to relay the chat messages. There is also the possibility to balance the store forward load at the instant messaging server, and it's being easily integrated with the previous version, with version 1. There is already a prototype implemented that is being tested right now. Another important activity done also by University of Southampton was the porting of Vocal. There is also a collaboration between 6net and Euro 6 on this porting. The work has been done by a researcher between degree and PhD, and this is actually being used in 6net, 6WINIT, and Euro 6. It's important to mention that, of course, the quality of the voice depends largely on latencies on the hardware that you use for using this tool. A next step could be the moving to integration of Vocal with Inam, and there are a lot of issues that need to be sorted out here. And that's all from my side. I think I was very fast, maybe, helping to catch up with the timing.
Really, thank you so much. Are there any questions from the audience? So thank you again for that interesting overview about the Internet Exchange and IPv6. And I would like to introduce our next speaker. It's Marian Garcia Vidondo. And we will hear about IPv6 on Xi'an. Marian, please.
Yes, but I don't have any. Yes, good morning, everybody. My name is Marian Garcia. I'm the operations manager at Dante. I just wanted to do a brief introduction about why I'm here. Dante and some national research networks were part of the 6net project, and where as a testbed we learn and gain valuable experience. I want to give now another point of view from the operations point of view. I will speak about the operational network for IPv6. So I know that the most part of you already know about Dante and Giant, but there are a couple of slides that I will just go through quickly to explain what is Dante and what is Giant. So Dante is the company I'm working. It's a non-profit organization established in 1993 by the National Research and Educational Networks. So I will call them NRNs from now. And the role is to organize, to manage, and to build the Giant network. So what is the Giant network? Giant network is a 10 gigabit pan-European research network. It's connecting 32 countries and is serving more than 3,000 research entities across Europe. At the same time, it's providing international connectivity to other world regions like ABELIN and ISNet are the national research networks in North America, CANET in Canada, and SciNet in Japan. GIANT is jointly funded by the National Research Network and by the European Commission. So here we got the topology map. There is GIANT. The square represents the countries. The black lines represent the 10 gigabit links. We see that we cover from east to west Europe. We have connectivity with Estonia, Latvia, Lithuania, even with Turkey. Let's see if I can use. Where is the pointer? Okay. Yes, perfect. Yeah, thanks. So we got connectivity with countries like Turkey, Israel, and Estonia, Latvia, Lithuania. We'll have connectivity with Russia in the next few days. So once I've introduced Giant, let's see what we have done in Giant for IPv6. As I said, Giant is an operational network that is providing transit traffic to the National Research Network. And at the end of the last year, we decided to implement IPv6 as an operational service. So the plans that we did was to have the Giant backbone dual stack, and we planned this for the February this year, and it has been done. We established the first connections in April this year, and we are planning to provide a pilot service, full pilot service for all the National Research Network for the June this year, and to have a full operational service for October. So I will go a bit more in detail in these points. So what we did, that was December last year. First of all, we started to think, what do we need for implemented IPv6? So Giant was running OSPF v2, so we needed to change the IGP, and we decided to migrate to ISIS. So currently, ISIS is handling both B4 and B6 routes in a concurrent topology. So I will say that this work was 90% planning and 10% implementation, and it was really successful because no one of our customers noticed actually that we were changing the IGP. The second point we have to study was the BGP design. So there were several questions. Should we use one TCP session? Should we use one TCP session for B4 and B6, two TCP sessions? Obviously, we saw some advantages using only one TCP sessions. Obviously, it wasn't going to be duplicated. But we saw some disadvantages. So when we were doing a lab and we were testing this, we realized that the next hop chosen by the IPv6 NLI was derived from the IPv4 address, and it wasn't the IPv6 address that we actually configured in the links. So there we had an IPv6 address in our IGP, but the one that Netscope was choosing, it was an IP address that it wasn't in our routing table. So that made things a bit more complicated, and we needed to configure some static routes. So we decided to go for 2 TCP sessions, one for V4 and one for V6. So all was done around December last year. So we planned the migration, the IGP, we planned the BGP design, and what was the next step? Well, here I just wanted to make a brief summary of what is the ISIS design at the moment. We got only level 2 routers, and we can see here the routers that we are using in Giant. Mainly we are using Juniper routers. We got N160s and N40s, and the Junos version we are running now is the 5.5 release 3. We got 2 Cisco routers in our network. They are 7507, and they are located in Luxembourg and Israel, running a 12.2.13T. So as I said, when we got the ISIS implemented, when we got the BGP design, then we started to work in the addressing plan. We requested an /32 from Drive, so Dante got this /32, and from this /32, we assigned one /35 for Giant. As you can see, there is another /35 assigned to 6net. And there is a /35 reserved for delegation for projects. So we will assign /40 or /48, depending on the size of the project. We reserve some /36 for delegation to the NRNs if needed. At the moment, we haven't had any requests. That means that all the NRNs have gone to RIPE to request their own /32. And we reserve the last /35 for a possible migration later on. So a few more details about the addressing plan. From the /35 assigned to Giant, we got an /40 for the core backbone. And then we start to address the POPs. I just will go briefly through this addressing. You can see for the POP addressing, we assign an /48. And we got the last 8 bits will indicate the POP number. So it will help us to know to which POP are we referring with in a specific IP address. And within each POP, we will address VLANs, access lists, tunnels, loopbacks, and a testbed. So we get, for example, this example, access links. We got okay, yeah, thanks. Yes, the access link. We see here one of the samples. These 8 bits represent the POPs. These 4 bits represent the router in each POP, and the AA will represent that is an access link. So it's a way, I mean, the IPv6 addresses are really difficult to remember, but it's a way to organize and to have an idea what this one IPv6 address represents for us. And for example, the same example I was giving before, the access links, we allocate an /126 for a point-to-point link. And for example, for a POP in Frankfurt, as we said, the PX, these 8 bits, represent the POP. In this case, is the number 14. These 4 bits represent the router, so it's the router number 1, and the AA is the access. So it's a /64 that then it will be divided in a /126 for each one of the links. For a trunk, for example, well, the addressing range for the trunks it will be as well as /48. And for each trunk in Giant, we have an /80 allocated. And again, the same, CCC will represent the trunk, PX will represent the POP, this 4 bits will represent the router, again, the second POP and the second router. And again, it will be divided in different /1 to 6 for each one of the parallel links. Right. So we got the routing policies as well to be defined. So we followed, as we said, different steps in this deployment. So once we got the addressing plan, once we got the appropriate IGP, then we go about the routing policies that we are going to apply. So from the national research networks as our customers, and we transit traffic from them, we will accept prefixes between /35 to /32 from national research entities. That means that anything else outside this range will be filtered out. So then we encourage a national research network for aggregation. We will accept 2002/16, and we will accept 6-bomb prefixes for a limited period of time. So we know that some of the national research network still are using these 6-bomb prefixes, or some universities within these national research networks. So obviously we want to give them time to renumber, and it's like a transition phase. And what we will export them? Well, obviously we will originate the /32 that we get from RIPE. And we will announce then the rest to one NRN, we will announce the rest of the national research networks, as well as another research network, as I said before, Abilene and YesNet in the US, Canary in Canada, and SANET in Japan. So what's the current status in GEANT? GEANT is a dual stack since February. We got several national research networks already connected. Here we got the list. We got different native connections. We got tunnels. Here, well, is the national research network, and next is the country. So Retir is in Spain, Renater in France. Well, we'll go through all of them. So we got 14 national research networks already connected with a V6 peering to GEANT. For another research networks, well, we got already Abilene as well. So we got a V6 peering with Abilene. It's a native connection. We got more than 200 routes at the moment received from Abilene. Again, we filter from Abilene everything that is outside the range /32 to /35. And here is an example of what we are receiving from Abilene at this moment. So we receive some routes from the Aryan region, universities in Indiana, Wisconsin. We receive from the LACNIC region, we receive Mexico, for example. From the APNIC region, we receive White, or some Singapore, NRNs, Taiwan, Korea. And for the rest of the research networks, well, currently we are working on it. We'll have a dual stack connection to YesNet, the second national research network in North America, and we'll have a tunnel connection to SANET in Japan. For other networks, well, we have configured at the moment a tunnel connection with Telia in an experimental basis. So, and we are working in a tunnel connection with Global Crossing, but as well, as I said, in an experimental basis. These two providers, internet providers at the moment, are not able to provide a dual stack connection. So, what is remaining to do? Well, the routing policy between GEANT and 6NET needs to be implemented. So the objective is to provide connectivity through GEANT and through 6NET between or two NRNs that only are connected to GEANT and NRNs only connected to 6NET. So this will be done in the next few days. We are working in the monitoring as well. It's an important thing to monitor the amount of IPv6 traffic that we are having in our network. And we are working in the definition of the service. So just very briefly, we got some ideas about the IPv6 monitoring. Well, the first option is the use of firewall filters in the interfaces. Remember, we are having Juniper routers, and it's the easier way to monitor the traffic. But some of our NRNs came up with new ideas, for example, to change the framing. Currently, we are having Cisco SDLC and PPP, so we could change the framing to frame relay and to use different DLCIs for V4 and V6, but this needs to be tested. So more or less that's it. Here I give you some references, some websites where you can check the information of the work that is done at the moment. This is the GEAN B6 Task Force. It's built, or Dante is part of this GEAN B6 Task Force, as well as some national research networks. So you can get more information here, or you can write an email. You are welcome to ask any question that you feel. And I think that was it. Yeah, that's it. So if anyone got any questions? Yes?
For you, Marianne, Theo, and Bernhard, I want to understand more how the cooperation of SIXNet and XEAN works and how the knowledge is transferring to XEAN. Additionally, Marianne, you mentioned that there are some NRENs that are only connected to SIXNet but not to XEAN?
Yes, they are, but it's just a temporary situation. Okay. So all the NRNs connected to XEAN can connect via V6 whenever they are ready for that. In the meanwhile, while they are doing all this preparation, we want to assure that all the NRNs can have traffic between them. So some of these NRNs are connected to SIXNet, and some of them are connected to XEAN. So we will transit the traffic to ensure that all the NRNs can transit traffic between them.
So this has been very well defined from the beginning of the SIXNet project. The Dante and XEAN network is an operational network with service level agreements, so it has to be up all the time. The SIXNet is a testbed, is an experimental disruptive network where we can do crazy tests. We can break it on purpose. We could test all the things which you never can do on an operational environment. So we exist with next to each other, and it's also the objective that all the good experience we have will be transferred to the XEAN network so that they benefit, of course, of the outcome of SIXNet.
Yes. You mentioned that XEAN is connected to Korean, I think, in Korea.
It's not a direct connection to Korea. We can go back. We get transit towards, at this moment, for V6 towards Abilene.
To where, please?
Yeah. Let's go
in US.
to my slide. This one?
Yes.
Yeah, it's through the link to Abilene. We receive routes. So Abilene is announcing different routes from different national research networks at the moment, and one of the ones that we got is from Korea.
Is in US, Abilene?
Yes, yes, the internet too. Yes.
Yes, because I wanted to know, because when we tried to make some tests, we were directed to 6TAP before going to Korea, I think.
There's also a direct V6 connection between Renater that goes directly to South Korea.
From Renater?
Yes.
I'm not sure.
No, I'm very sure, because the French government pays for it. So.
Because last week we tested, but it was transited to 6TAP.
Well, have a word with Bernard too, or Danny Van Rom is around, so he can explain you what are the methods, mechanism to access that link.
Okay.
It's quite a sensitive issue. So.
Hello, Yves Poff from Canada. One question, within the Canary context, we had a big debate on address allocation. So Canary has a /32 and allocates blocks to the provincial networks, which would be the equivalent of NRANs in the European context. Now, some of the NRANs have their own /32s, and some others get /32s from Canary, and some others have both. So the whole issue came up of multi-homing and whether or not Canary should recognize the routes, all the blocks from the NRANs, the local networks below. And I was wondering how it works in Europe. Does XEAN also allocate pieces, address blocks to NRANs, or all NRANs have the responsibility to go and get their own blocks?
Okay, what we advise is to get their own. to get their own blocks. If they need it for us to delegate, we reserve some /36. So there were some conditions. So we delegate in /36, but obviously we are the upstream. So we don't delegate /35 or bigger than /36. So we offer this opportunity to the National Research Networks, but we haven't had any request. So the National Research Network have gone to RIPE and have requested their own /32. So my answer is we don't have this issue at the moment because there haven't been any requests from the National Research Network. But if we do allocate, we will have some conditions, and the maximum range that we will allocate is /36, and we will be the only upstream.
Thank you. If additionally to that, of course, RIRs have a common policy for the address allocation. But of course, we have the ARIN in America, and Canary has to go to ARIN for addresses, and there might be some slight differences from time to time in how the rules are applied. But anyway, the scope is organizational. So if Canary has an address space and it is not enough, then you can go to ARIN back and get more for the regional networks. So I guess it is not true to say that the regional networks there are the same as the NRANs in Europe, because these are organizational differences, to my opinion.
Thank you so much, Marian. We have our next speaker, Bernhard Fabianek, about IPv6 in the 6 framework. This should be the last session before the break, and when we make some slight changes because we are slightly running out of time. Bernhard.
And I just want to start with a little bit of bureaucracy, of course. What is the framework program? What is the information society technology's priority in it? And of course, what is the funding available? And then come to what IPv6 could do in that aspect, and maybe try to, well, give some hints or at least stimulate discussion for the break afterwards, and how IPv6 could develop further, or at least what we in our ivory tower have discovered. Now, framework program is, of course, complicated, many different boxes of areas of research. The main ones that are always discussed are these thematic priorities, and in them our Director General certainly is dealing with the information society technologies, this bit here. Then there's some kind of generic stuff, and because it's a research networking conference, here at the bottom the work on GEON and grid sits, but we're not discussing this here. So I'm focusing on what is available there in information society technologies. Now, if you go into that yellow box, it becomes even more complicated. But I would say it's not so bad, because we don't have the time to go through all of these texts, but you have even the word IPv6 mentioned here, you have security issues discussed at the conference, even grid stuff, while e-learning, cultural, we had sort of the introduction and the plenary session, and maybe this microelectronic stuff is not so relevant here, but again, interfaces, semantic web stuff. So it's all actually highly relevant to this community, so I just invite you to have a look at the work program and see where there are opportunities for funding and joint research. Now, the area of sort of our unit is dealing with, and then sort of I have to make a little bit of promotion, of course, is what is called research networking testbeds. That is, well, you have seen the presentation from Euro 6 and 6net, so they fall under this category. And, well, we try to build on the good examples and the achievements they have made and to continue in that spirit. And it's to integrate and validate within the context of a large, hopefully user-driven testbed, sort of new technologies that are state-of-the-art or even hopefully beyond, just coming out of research labs, to see how they perform in a large environment before you can go out and use them in a production environment. So there's some kind of a value chain that, again, is visible in the IST priority. You have the components development, being software or hardware. Then you have the systems projects. And at the end, you would have the test beds before it's released into the sort of normal production environment and business. Now, the funding opportunities, the current first call of the IST program has already closed. So it's the second call that will be published mid of June, with a deadline of mid of October. And in the case of testbeds, there's a budget of around 25 million euros available. We just would like to invite you again to sort of form large multidisciplinary consortia, like Euro 6 or 6net, for example, that come from different sectors, bring their expertise from these areas. And of course, you have already now the experience how this works. In the beginning, certainly it was not easy. I remember discussing with Theo all summer and negotiating the projects. So I think now there is some know-how on how one can manage and operate this project, because also the project itself has to find out how this works. So that is quite good to see. Now, yeah, you find some information on the web on these things. Coming to the future of IPv6, I would like to compare V6 with, I would say, the car industry or sort of transport industry. I mean, we are now at the position where we have developed the motorways. Marianne explained that Jean is all there and everything is V6 enabled. We have the cars so that all the various boxes can talk V6. We have the cookbooks, so that is sort of the driving licenses and the courses that tell you how to use the new motorways. But still people are thinking that it's nice just to walk or hike or take the bike. So what I would say, as a little bit of criticism maybe, is how can we convince the people that driving cars is better than just walking around? And of course, if it's raining, everybody agrees that it's better to use a car. But I think these scenarios where V6 is better or clearly of an advantage compared to V4, we haven't sort of found them yet. Because people say, well, V6 is nice, we deploy it, some of us use it, but actually it's a hassle. So if you are just a normal university network center man, why should you deploy it? It probably makes your life just more complicated. Where are the benefits of V6? Now, yes, you have seen Jean, it's there, so Marianne spoke a lot of it. Now, what is the future? Is it the black hole of V6? Will it follow ATM, an over-engineered solution? It is, well, was hardly used, now it's more widely used. So. Or is it a sort of bright future that it becomes like SMS? It's sort of a big business case. Not really that SMS is a good service, but everybody uses it, and telcos are making big money out of it. So maybe you have to find some way how V6 sort of transforms the way we sort of live, and then, I don't know, sends fancy pictures or something like that only V6 can do. Or maybe it's what we have heard in the introductory plenary, that culture needs V6. Or maybe the future is not orange, actually, it's blue. So maybe V6 is like water, and I want to sort of fall on that analogy, and maybe that's some food for thought. Water fulfills our basic needs. Well, it rains down on us, so it's just a nuisance maybe even. Well, we need to drink it, otherwise we just can't keep on living. And also, they're efficient water, so we can eat. And the analogy to V6 would be that, well, it has the address space that we need. I mean, it's clear that we're running out of it sooner or later. It re-established the end-to-end paradigm. So that's some, I would say, the basic internet stuff, and we probably agree all on that. Next thing would be, like water, it helps on trade and commerce. Well, you have ships that sort of transport the stuff on the water. You can irrigate and have sort of a better performance in the plants and all the things that you grow there. Or you can use it for defense, like castles with water around it. And again, the analogy would be e-commerce and security. So when you think that water initially was just providing stuff to drink, you end up with something that's much more complicated and versatile, actually. And maybe we just have to think about these solutions for V6 as well. And the last thing, even if you continue with water, it improves the quality of life. You sort of can wash so that we have cleaner clothes, you can have sewage systems, and you can even have fun with it. It's just for pleasure, like a fountain or whatever that has no real function. And I think that's what we have to do with V6. We have to find the applications where V6 is really fun to have it. Well, sorry, we don't have the solution for that yet. Apologies for that. Now, a little bit of a vision, but that's more generic. You have a range of science applications together with some kind of technologies, and you have some kind of an e-infrastructure that is IPv6 and grids and high-speed enabled that sort of brings these things together and allows them to interact. You also have people interacting with that infrastructure. You have machines, and then people and machines interacting, and we try to create this global knowledge infrastructure. Again, V6 could be just the glue that holds all that together. A little bit of policy, because still we're coming out of Brussels. Certainly, V6 and e-infrastructure is the cornerstone of the European research area. That is the new common market for research, as we call it, so that researchers are free to apply for jobs and research grants everywhere in Europe, so you're not restricted to stay working in your country, in your environment. And of course, we had the EU-Europe Action Plan, EU-Europe Plus in Eastern Europe, and now there's new incarnations of that things, and V6 is all part of that, and with Jean, we fulfilled one of the requirements to have high-speed research to the researchers, and then high-speed connectivity to help them to do their work. It helps to integrate national infrastructures, like Marianne presented, that everybody is gearing up for V6, so we are there. It helps international cooperation, again, with other parts in the world, and, well, we are all happily living on together. So we can conclude that some of the money we spend, actually it's taxpayers' money, was wisely spent, and we hope that the V6 projects really find the fun behind it. And yes, with all other related activities like geoing grids, the research community was able to benefit a lot, and we hope to keep that for the future to even make the European research area better. Thank you. I was just sticking to the time. Any questions? I have the book with me with all the funding opportunities, so if somebody wants to come and talk, you can download it from the web as well. Okay.
Thank you, Bernhard. Can we make our break now? I would ask you to be back sharply at 11 because we are running out of time, and we will put this session about Liberator in the next session when. So please be back at 11.